Hey, I'm Jarrett Morgan with Possum Solutions, and today I want to talk to you about my Productive Robotics OB7 robot integrated with my mill, and why I did things, how I did things, and maybe give you an idea of doing a relatively cheap robot pallet pull cell yourself. This is not going to be a step-by-step how-to instructional video. Things will change based on your machine, your robot, your part constraints, all those sort of things. This is just sort of me wanting to share what I figured out through brute force and what I was told by, people that helped me out, and people seem to want to hear more about this, so here we are. One of the big questions I get is why I did sort of pallet loading over part loading. Part loading seems to be relatively easier, but there are two big reasons that I did pallet loading. The first is just quantity. I'm normally in like the 10 to 40 range of parts, and having to reset the grippers every time for the different size stock, or have to move the air vise, stuff like this. This way the vices are all the same, it's the same template infusion, all that stuff's super simple. The second reason is that I want to do sort of fake 5-axis for more complex parts. These are just 3-axis parts that just finished up here, but I can take this vice pallet, put it in the 3-axis 0 point, and then have the robot pick it up, move it over to the 4-axis 0 point, and rotate it around, and sort of access 5 sides of the part in that sort of fake 5-axis that ends up being very helpful for the more complex parts that I do. The other big question I get is how much was it? Sort of my intent going into this project was to see how cheaply I could get into quote-unquote like real automation, to try and see how it was, if it worked for me, sort of all that jazz. I didn't want to go out and spend 80 to 180 grand on a full automation package from one of the more turnkey companies. I like figuring things out. I sort of like bootstrapping a little bit. So I went to IMTS this year, not necessarily with the goal of finding a robot, but I ran into the Productive Robotics folks in the back of the main hall. Played around with the robot a little bit. They gave me a sort of programming demo, and it's very easy to program. I liked it. I was in talks with them. I ended up searching around to try and find maybe a used one. I found this particular robot on eBay for right at $20,000 plus shipping and tax. I then probably have another $6,000 or $7,000 in sensors and auto doors, 0-point systems, vices, the stock, the studs, all the little extraneous things, airlines, fittings, a rotary union for the 4th axis, all that stuff. So I'm at about $26,000, $28,000 all in on this, which is pretty cheap for a full robot. And I think so far I've been very happy with it, especially for that price. So let's talk about the robot itself. This is the OB7 Productive Robotics. It is a 5 kilogram robot, about 11 pounds. I think it has just under 1 meter of reach. It is 7 segment rather than 6, which they say means that you're able to sort of reach around inside lathe chucks, or reach around obstacles and have sort of a better maneuverability. It is the only robot I've ever had, so take everything I say with a grain of salt because I don't really know what I'm doing. It seems to be pretty good. It seems to not quite have the maybe stiffness of other more expensive actual robots versus the cobots, but it's very easy to use. It's been very reliable. The software is absurdly simple in a great way. Has plenty of I/O in the box, and so far it's just kind of worked. So I don't have too much to complain about, honestly. At the end, we have the end effector here. The way you sort of program the robot is by pressing these little buttons here. There's 2 here and 2 here, and by pressing it, it sort of releases the robot, lets you move it around, and when you release it, it stays in position. You can then set keyframes based on that. The gripper this one comes with, which I think has been updated in the newest models, is here. There's buttons on the back that let you close and open the grippers. It's a pretty interesting mechanism in here, actually. It's sort of 2 rollers, but there's a motor with a worm gear, and these are attached via this belt together to move together. So it's an interesting system. It seems pretty robust. All I did was 3D print these little angle pieces on the ends. This was meant to be a temporary solution, but as we all know, there's nothing more permanent than a temporary solution. And the intent behind this is basically on the pallets themselves, I have a matching sort of slot here, and so as it goes in and clamps, it sort of self-aligns. And so what I'm using is the slots themselves, and then clicking all the way in to get the third axis. So once we're in there, we're very secure, and it ends up being quite repeatable. At the robot base, you have some connectors here. We also have our actual control software down here along with the I/O board. The I/O box has M12 connectors on it that let you do I/O on it. But the main way you interface with it is via this tablet. It's really quite simple. It's all drag and drop. I can go into one of my jobs here, and this is the entire job. And it's all just moves, opens, pickups, grips, pushes, drops offs. All of the options are on the left here, and you can do if-then statements, if-else statements. You can do repeats, all this sort of stuff. So it's pretty powerful, but it's also very manual. So it's not going in and writing code, nothing like that. You can't really go into the computer, it seems, and write programs, which is great in terms of being easy, is less great in terms of trying to get really into the weeds of it. So the way I have it set up, basically, each of the positions on the pallet pool is in here as a separate position, a separate location. You can do grids, but it seems that actually indicating each position is much more accurate, and so that's what I've been doing. And then basically, I go through the whole process, wait for the robot finish signal to happen, and then I just repeat however many times. So if I come in here and I want to only do 5 parts, I can come in here and just hit 5, and now it's only going to go to the first 5 pallets. So that's sort of how I do it. The robot controls everything. It controls the auto door, it controls the pneumatic bases. Everything is done through here, and the talking back and forth of the machine is only through an M code and M finish. So integrating into the machine is actually not that bad at all. There's 2 relays. The machine controls one and the robot controls one. The machine controlled relay, excuse the noise, my shopmate is working. The machine controlled relay is actually a machine relay here that is started with an M code, and it outputs 24 volt that is supplied from the robot. We want to keep those 2 voltage systems separate. So the robot gives 24 volts in, and when this relay closes, that 24 volt signal is sent back out to the robot. On the robot side, I have a little relay block here that's powered by the robot, but then I use machine 24 volt in the relay here to give the machine the M finish signal. So all the actual talking back and forth between the robot and the machine are just 2 relays in the back of the machine here. So as I said before, the robot controls everything, but the machine is in charge of actuating the robot. So my order of operations here in my main robot program, which is just O100, arbitrarily speaking, main program here, and that's what I changed. The M198 is just calling it off the CF card here. P111 is our blow-off chip and conveyor program. 1050 is our robot program, and 7100 is our probing program. If we go more into this, we can see that O1050 is pretty simple. I want to make sure that whenever I call the robot, the table of the machine is always in the right position no matter what. So if I only call the program, not the M code, the program is going to make sure that our table goes to G53 X200 Y0, and that's where the robot's expecting it, and then it calls our M code. I got a bit lucky with this machine. This is the higher end series Fanuc on this 2412 that is set up to either do a full 4-axis or a 4-axis indexer. So I'm using the full 4-axis, actual A-axis for my 4th, but I'm using one of the M codes for the indexer to give a M code out signal and then wait for an M finish signal in. So when it hits that M1050 here, the machine will pause until our robot sends back a signal saying that it's finished. So the 0 point system I have in here is by Silver CNC. I've used them for the 4th axis in this machine, the probing in this machine, the probing on the Haas. I've been very happy with everything they made. I was looking for a 0 point pneumatic, 52 millimeter specifically setup. It seemed like there's a couple manufacturers that make them, but it's not super common. And I already had a good experience with them, and I liked that they have, it's spring actuated inside, but they actually are able to use what they call a quote-unquote turbo mode, but essentially the piston inside is dual acting, so you can put air pressure on the opposite side and the open side and clamp a little harder. They claim that it has the same clamping force as their mechanical 0 points, and so far that has been the case for me. They have been very reliable, and I can machine on them just as hard as I would on the mechanical 0 points. The goal is to have 2 of them, one on the 4th axis, one on the 3 axis. So like I said, I can do that sort of fake 5 axis style thing. On the 4th axis here, obviously the 0 point is centered in rotation, and I ended up having to build a little backing plate here. The ports are on the side of the silver CNC pneumatic, and obviously I need to go through the through bore, the 4th axis. So a good friend of mine let me come borrow his surface grinder and grind as flat as I could for being a novice, spacer plate that let me bring in the tubing to actuate the 4th axis here. In addition, this is the gimbal automation rotary union. They've been very helpful, even though I haven't actually bought their spindle grippers or anything in this whole process. The rotary union is fantastic. It ends up being very easy to install and lets me not to worry about, kinking airlines or whatever. I can do 360-degree rotations on the 4th axis, all that stuff. Another really important thing for me was to be able to stop the machine remotely. I have a webcam hooked up, I can check in on it, but let's say the coolant overflows, let's say it errors out in some way, I want to be able to hit the Estop, don't think about it, it's all fine. So I got this little Wi-Fi relay board. It's to control kind of anything. I hooked it into the Estop circuit, and I can press it on my phone and the machine E-stops. Another big concern is coolant. The coolant needs to stay in the machine. If it's out of the machine, we want the machine to stop. I have had some smaller spills in the past, and if I'm here, I can catch it pretty quickly, not a big deal. The robot's running overnight. I do not want that to happen. So the way I get around that is having the chip conveyor run in between each robot load. There's a 30-second delay where it just runs, and that's enough to clear the entire exposed section of conveyor. And 2, I got water heater sensors from the same manufacturer as the relay for the E-stop in the machine, and they can talk to each other. So if those sensors sense coolant, water in this case, it will trip, the machine will E-stop, and hopefully the spill is relatively contained. Another piece of the puzzle is an auto door. Initially I had the robot closing and opening the door by itself. Some folks on Instagram reached out and told me that could lead to some premature joint wear. So I picked up a pretty cheap 700mm stroke piston, 3D printed some adapters to 80/20 extrusion, attached the 80/20 extrusion to the top of the machine, and machined a small bracket down here to attach the rod end to the door. It works pretty well. The robot controls it like everything else. So along with the auto door, I wanted some way to make sure that the robot knew the door was shut, so I didn't have to deal with potentially having coolant spray everywhere. I got a relatively cheap little induction sensor and used an old T-nut that doesn't fit my tables, and there we have a door open close sensor. Another piece of the puzzle is probing. I want to make sure that when the robot loads the pallets in there, if there's a misload, if something gets wrong, it runs into something, the machine doesn't run and fling a pallet, break a bunch of tools, etc., etc. I have tool break detect on all the tools I'm worried about. Pretty much everything but the face mill, which is just doing finishing passes, I run tool break detection on. And then I also have a program that I have combined some fusion output and some simple macro logic to probe all 4 corners of both of the pallets on the 3-axis and the 4-axis to ensure that the pallet has seated within a certain amount. I think I have it plus or minus 5 thou right now. Currently, that has caught an issue once, and I was able to rectify the initial cause of that issue, and it hasn't happened since. But it's nice security to know the machine checks the pallet placement. So machine is on now, forgive the noise. I'm going to sort of walk you through the general thought process and sort of how I run this robot when I run it. So I have 13 spots and 12 pallets. It's sort of the idea that because the robot can only pick up 1 pallet at a time, there needs to be 1 empty spot that I can take and give. So I can run 10 iterations of whatever part I'm doing. So let's pretend that all of these parts currently have stock in them. I would take my robot control pendant here, hit work, 3-axis, just to do one, and hit go. The first thing it's going to do is it's going to release the 3-axis 0 point, clamp it, release it, clamp it. I had an issue early on where if it sat overnight and then ran again, the coolant would sort of form a seal and it would be hard for the robot to pick up that 3-axis thing. Doing this at the beginning has never had an issue before. I found that honestly most of the time, most of the integrating issues that I've had with the robot has been finding out when problems happen and then solving those problems. So I hit go, it moves to its start position. You hear the pneumatic solenoid click on, click off, and now it's ready. So now it's saying waiting for machine ready on. At this point, the robot is static, still waiting for the first thing. On the machine itself now, I'm going to come over here, and I know that that part in there is already done. I've proved it out. We're ready to actually do the robot run. Let me start the robot. So I'm going to scroll down to my 1050 program here, which is just telling the robot that it's on. So it's going to, it's change position now on the table, the door has opened, the robot's coming in for that 3-axis. It's going to come in here, it's going to grab the part, wait a moment, pick it up. So the next thing it does here is it's going to take the part and make sure it's seated in the jaws of the robot well. Another issue I had early on was sometimes when things got a little sticky, that robot, as it pulled it out, would slide it out of the jaws just slightly. The solve for that was to do a push action on the robot and just make sure it just eases in and sits against the rear of the jaws to make sure that it's located correctly. It's going to go now and put the vise up at the top left. It's now going to pick up the next vise because we're in 3-axis mode. There's no changing from the 3-axis to the 4-axis. So before it puts it in, it's very important that it's going to do the same push action to make sure that it's located where the robot thinks it's located. That little push. Releases it and pulls out. Now it's going to come up, go back to its home position, close the door, and it's going to start the program. Overall, the robot has been, for lack of a less buzzy word, a real game changer for me and Possum Solutions. As a one-man shop that I occasionally bring a buddy in to help ship stuff and whatnot, it's bought me a lot of time. It doesn't replace an employee, but it definitely lets me focus on going to meet clients, shipping things, working on new products, and let the robot just run in the background. There's been a couple weeks when I've had some real sort of trying to get a bunch of stuff out and doing runs for 4 or 5 hours overnight after I go home has been huge. It's been very reliable. The couple issues that I've had have mostly been coolant and chip related. It has a chip conveyor. It has a good coolant pump, but at one point the coolant foamed, had a little bit of spill. It's a bummer. But the robot itself and the pneumatic 0 points have been dead reliable. I cannot recommend them enough, especially for the cost of Productive Robotics, and what it buys me is huge. Please reach out if you have any questions. I'm happy to answer any or give any tips or tricks or whatever. Like I've said before, this is not a how-to video. I am not an expert. I'm brute forcing this in for you as I go along. If you have actual robot questions, there are some great companies out there that are doing incredible robot integrations that are completely turnkey. And if you have the money, that's where I do it. But I don't have the money and like learn things, so this is where I ended up. Thanks so much for watching. I hope you enjoyed the video.